All right, picking back up at 26, in 2009, a survey of internet usage found that 79% of adults age 18 years and older in the United States uses the internet. A broadband company believes that the percent is greater now than it was in 2009 and will conduct a survey. The company plans to construct a 98% confidence interval to estimate the current percent and wants the margin of error to be no more than 2.5 percent points. Assuming that at least 79% of adults use the internet, which of the following should be used to find the sample size needed? Now, they did tell us that assuming at least 79% of adults use the internet, so we can use that for our proportion, for our p-hat, since we have that information, right? So right off the bat, we can kind of get rid of A, B, and C, and we're going to look at D and E because of the 79% as our p-hat, and 1 minus 79% is going to be 0.21. So the next thing we're going to do is we need to figure out what our critical value would be. So for a critical value, that corresponds to a 98% confidence interval. We're going to go to inverse norm. Okay, 98% confidence interval means 2% on the outside, so a single tail would be 1%. So I'm going to put in 0.01 as my area. I'm going to hit OK. And that's going to give me my critical value of 2.33. Well, if you look, D and E both have a critical value of 2.33, right? So we're still looking at either D or E being the correct choice. Now it's going to come down to the fact that they said they want our margin of error to be no more than 2.5 percentage points. So that means our margin of error should be less than or equal to 0.025. Right, and so in this case, our answer is going to be D. All right, so if we look at 27, a manufacturer claims its brand A batteries last longer than its competitor's brand B batteries. 9 batteries of each brand are tested independently, and the hours of battery life are shown in the table below. Provided that the assumption for inferences are met, okay, which of the following tests should be conducted to determine if brand A batteries do in fact last longer than brand B batteries? All right, so in this case, we are comparing 2 different samples. Okay, so we know that we're looking at brand A versus brand B, and specifically, we're looking to see if brand A batteries last longer than brand B. So this is going to be a one-sided test. We're not looking for a difference. We want to see specifically if A is better than B. So it is going to be a one-sided test, which gets rid of answer choices C and E for us. Right? We do not know anything about the population standard deviation. So in this case, right, we are going to go ahead and say that this is going to be a t-test, right? And we'll go ahead and get rid of D. And so now we're just choosing between A and B, a one-sided pair t-test, or B, which is a one-sided two-sample t-test. In this case, we're just comparing 2 different samples. We're not pairing them up. We're not matching them by any specific characteristics. Right, we're comparing 2 different samples. So this one, our best choice would be B, which is a one-sided two-sample t-test. All right, looking at 28, an experimenter conducted a 2-tailed hypothesis test on a set of data and obtained a p-value of 0.44. If the experiment had conducted a 1-tailed test on the same set of data, which of the following is true about the possible p-values that the experimenter could have obtained? All right, in this case, if it's 2-sided and we have a p-value of 0.44, right, the possible p-values that we're going to get are going to be between 0.22 and 0.78. Now the reason for this is going to be if we were to sketch out a normal model, all right, and we had a p-value of 0.44, but this was 2-sided. That means the one side was going to be 0.22, and over here this is going to be another 0.22. All right, so this is what we initially had when it was 2-sided. If we had a one-sided test, then that means we could be looking at, all right, just less than, all right, or just greater than. And so if we were looking at, all right, a p-value, if our alternative was that it's going to be less than, then we would just be looking at one side, which means we could have an area of 0.22, or our less than could be from our positive critical value, which would be this whole area over here, all right, which is where we get the 0.78. All right, so it could be either or, 0.22 or 0.78. And the same thing would happen if we were talking about greater than. All right, if we had greater than, we could be looking at from our positive critical value. Okay, anything greater than that would be 0.22, or we could have, all right, anything greater than our negative critical value, which again is going to give us an area of 0.78. Right, so this one's a little tricky because initially your initial gut might have been like, oh, 0.44, let's go ahead and just say that the only possible solution is 0.22, but you've got to think about the fact that we do have two critical values here, right? We have the negative z and the positive z. So in this case, our answer would actually be D. Question 29 says a randomized experiment was performed to determine whether two fertilizers A and B give different yields of tomatoes. A total of 33 tomato plants were grown, 16 using fertilizer A and 17 using fertilizer B. The distribution of the data did not show marked skewness, and there were no outliers in either data set. The results of the experiment are shown below. Which of the following statement best describes the conclusion that can be drawn from this experiment? All right, so they gave us the average number of tomatoes per plant for each fertilizer A and fertilizer B. They also gave us a standard deviation and the number of plants for both fertilizers. Okay, so if we look at our different options, right, we could go ahead and do a two-sample t-test. This is two samples. We're talking about mean number of tomatoes, so we're looking at the X bar, right? And we don't have a population standard deviation, so in this case it would be a two-sample t-test. So if we go to stats tests, we click on two-sample t-tests. All right, we don't have the data, but we do have the stats, so I'm going to go ahead and change that. All right, I'm going to call fertilizer A, I'm going to call that my first, or my sample mean number one. So that was 19.54 with a standard deviation of 3.68, and the sample size was 16. Now if I do the same thing for fertilizer B, we're at 23.39. Right, our standard deviation is 4.93, and our sample size is 17. All right, we are trying to ask, if you notice I wrote right here, they're just asking if it's different. So this is going to be two-sided, and we're going to say that the sample one is not equal to sample two. I'm going to go ahead and hit OK. And it's going to give me my p-value. My p-value is 0.01614. All right, so now if we go ahead and look at this, all right, we can come up and look at these different p-values that they gave us in part A. All right, I'm going to write this down. So my p-value was 0.016. All right, if we look at the p-value given to us, all right, here in A, they said the p-value is greater than 0.15. All right, that is not true. Okay, the next one says that my p-value is between 0.05 and 0.1. That is not true either. All right, and actually that was C. I skipped B. This is the one I just talked about, right? We've talked about A, we've talked about C, we said both of those are wrong. For part B, it says the p-value is between 0.1 and 0.15, right? That is incorrect as well. All right, and so that takes us to D, which says that U is greater than 0.01 but less than 0.05. That is true. So if we go ahead and read this whole statement, it says there is evidence of a statistically significant difference in the yields between fertilizer A and fertilizer B, with a p-value being between what we just said, that 0.01 and 0.05. All right, that is a true statement. All right, and if we look at E just to double check, it says the p-value is less than 0.01, which that is not true. All right, so in this case, D is going to be the correct answer. All right, with an alpha level of 0.05, we would reject the null. All right, this is statistically significant. All right, for 30, in order to plan its next advertising campaign, the Trendy Motor Vehicle Company is investigating whether the type of vehicle and the color of vehicle are related. Each person in a random sample of size 275 selected from the company's mailing list was classified according to the type, car or truck, and the color of the vehicle he or she drove. The data are shown in the table below. So we have vehicle color and we have vehicle type. Which of the following procedures would be most appropriate to use for investigating whether there is a relationship between vehicle type and color? So for this one, it is going to be a chi-squared test of independence. All right, we have two variables we're looking at. We're looking at the vehicle types and we're looking at the vehicle colors. All right, they're two different samples. They're two different categorical variables. All right, and then within each of those, we have specific variables, right? For color, we have red, black, white, tan, green, and then for types, we have car or truck. All right, so this one is going to be a chi-squared test for independence. All right, for 31, a large number of randomized experiments were conducted to determine whether taking a particular drug regularly would decrease the chance of getting a certain disease. For each of the experiments, the drug effect is the difference between the proportion of people taking the drug who got the disease and the proportion of people taking a placebo who got the disease. If the drug had no effect whatsoever, which of the following experimental results would be anticipated? So if the drug had no effect at all, then we would say that there's no difference between the placebo and the drug, right? So if we read the first one, it says a p-value will be greater than 0.05 for about 95% of the experiments. That would be true, right? If we had an alpha level of 0.05, okay, if there's no difference, then our p-value would be greater than 0.05 and we would fail to reject the null, right? So that one is going to be true. Number two, there will be about an equal number of experiments showing positive and negative values of the drug. All right, once again, if there's no effect, then this one will be true as well. All right, and then for number three, when 95% confidence intervals for the population drug effect are constructed, those confidence intervals will include 0 about 95% of the time. If there is no difference, then the confidence interval should include 0. And if it's a 95% confidence interval, then about 95% of those intervals that you create will capture 0. So 3 is correct as well, which means our answer choice for this one is going to be E. 1, 2, and 3 are correct. All right. I'm going to go ahead and stop it, and then we'll finish off the last couple problems in the next video.